Okay. This goes on page 58 when you are done. This is the only one you are getting today. We're going to have to finish this up tomorrow, and then we'll do some examples, and you'll get your assignment then. Okay, so you need to take out your 6 straws. Okay. We have class tomorrow. All right, you still have 7th period. And then so when we miss part of class because we all leave for the pep rally, then you're going to have to go back and watch the video because I will have finished this with every other class. Okay, so I want you to take your 6 straws, 3 different colors in each set, right? And you are going to create 2 different triangles with your 6 straws. Okay. And I know the straws roll around a little bit, and it's kind of frustrating. So if you can flatten them out, and they won't completely flatten out, and they won't stay flattened out, but it makes them less rolly. Makes them a little oblong, where they will, as I say that, it's like rolling away from me. As I say, with my straw rolling away. But it makes them a little easier to handle. So just flatten them a little bit, and then it's not as bad. Okay, so we're going to make our triangles. All right. Like so. Now, what do you have your triangles in front of you, so I'm going to move this so that I can just see one. Everybody should have 2 triangles completed. What do you think is true? What does it look like is true about your 2 triangles? Okay, they look like they're congruent, right? Do you have enough information? And it is scaling. I heard that too. Do you have enough information to say for sure that they're congruent at this point? No. Very good. Everybody else all day long has been, yeah, sure, all 3 sides are congruent. Great. Is that enough? No, because we have to have 3 sets of congruent sides, 3 sets of congruent angles. Do I have to actually know what the measurements are? No. I happen to know what these measurements are because we cut them yesterday, but other than that, you wouldn't even necessarily know, right? So all I know is that I have 3 sets of congruent sides. Everybody with me? So what we're going to do is take your ruler, and if your straws are on top of the paper you're writing, you might need to move them just a little bit. And at the top of your paper, underneath where it says Discovering Congruent Triangles, Part 1, you are going to draw a segment with the ruler. Make sure you know how to use a ruler and where the centimeters are. And your segment that you are going to draw is going to be 9 centimeters long to represent your 9 centimeter straw. Okay, so for me that represents my blue straw. So I'm going to take my blue straw out of the mix because the line segment I have on my paper now represents that straw. All right, so then you're going to take your straws. Now when you put the straws together to make a triangle, the straws are 3-dimensional, and sides of a triangle are not. You cannot put them together like this because that affects the way everything comes together, right? So you have to kind of pretend like they're 1-dimensional, and like you don't have to squish it down. I just want you to be able to see what I'm talking about. You see how it's just the edges coming together like that, like the very side of the straw? So you need to be kind of accurate on this, as accurate as you can be. And you're going to recreate your triangle, so just with those hitting the points, and then you're going to have to adjust it, and you're going to have to adjust your angles a little bit until you can get it where it all actually lines up. And I know it might seem ridiculous right now to be all careful with these straws. They're just going to move, but that's why you got to keep your hands on them so they don't move. Okay? Once you've got that and you feel like you really have made this triangle and things line up nicely, you can let go of one of the straws. Make sure you don't move the other one. Then with your pencil, you can make a little point right there where those 2 straws came together. Does that make sense? So I had this, and I got my triangle, so I'm putting a point with my pencil where that vertex is. So now I can move the other straw. Then I can take my ruler and I can connect that vertex to the end point of the segment, and I can create my triangle. And then the triangle you have should represent the straw triangle that you had. Like the measurements should be accurate and angles be the same as what you had with your straws, whole 9 yards. Okay? Everybody good? All right, so I'm going to label then, because somebody did say, I heard that it was scaling. It is a scaling triangle, so I'm going to label like that. This side is different than this side, which is different than this side. Okay. Then I'm going to repeat the same thing down here. Now, just for space purposes, so I can make sure I'm, I'm going to put mine where the base of the second triangle is down here, so it'll be like flipped around the other way. You don't have to do yours exactly like mine. That's fine. Just make sure that you actually measure 9 centimeters, and then you line your straws back up just like you did the first time. Okay, so you're doing this twice to get 2 triangles on here. Now, I know some of y'all are still drawing, but before you start, I want to make sure I say this before you start labeling things congruent. I know that this was 9 centimeters because I measured it, right? Then my other 2 straws are 5 centimeters and 6 centimeters. And depending on how I laid my straws back down, I got to make sure I line my triangle up correctly. So this is my 5 centimeter straw, which is my yellow one. It goes along the side that has 1 mark on it. So when I bring it down here, clearly that's not the right side. So this is the side that was my 5 centimeters. So I'm going to put 1 mark here and 2 here. Okay, so your marks may end up being different if you flipped your straws around, and that's okay. Yours does not have to match mine exactly. It just needs to be accurate according to whatever it is that you have. Okay, does everybody understand what to do? And what you're, okay. I mean, I know some of you are still drawing this. And if you happen to draw it and then your triangles overlap each other just because of the way it landed, that's okay. It's not the end of the world. Don't erase and start over because you don't have time for that. It's fine. And then after you draw them, so those of you that have both of them drawn already, do you feel like those 2 that you drew look congruent? Yeah, I mean, if you feel like the straws did, then those should, because that's supposed to just represent that on your paper without us gluing straws down in it and everything. All right, just going to give you a little bit more time to draw. We don't have time for everything to be perfect all the time. So now I want you to take your 110-degree angle out of your bag. I realized as I did this, even though I went through this a few times before I decided to do it in class on my own, that I should have had you do two 110-degree angles, and I didn't, but it's okay. So see if your 110-degree angle fits in this triangle. Now there's only one place really that it would even make sense, right? So you can try it there, and it should, in theory, it should fit exactly. But we cut these out of little pieces of paper and we're using straws, okay? So right now, if it is not perfect, it should be pretty darn close. Does that make sense? Pretty darn close is good enough for us because depending on exactly how you cut it and exactly how you laid it, maybe off a tiny bit, but for the most part, the 110 should fit there. Okay, does that work for you? And then check to see if that happens in the bottom one also. And it does. Again, pretty darn close. Mine actually looks pretty good. After doing this so many times today, I'm good now. All right. So then take it. Now you only have 1, and that's okay. But you're going to glue it down in one of the 2 triangles. It doesn't matter which one. Pick your favorite one. Pick the one it fit the best in so it looks the best. All right. I'm going to glue mine in my bottom one because I feel like it looked a little bit better there. And then we're just going to label the other one 110 degrees because we know that it is. We were able to measure with that angle even though we couldn't glue it down. That's fine. Because the angles really are those measurements. I created them myself to know that they really are those measurements. So that's why these things should work out okay. Now you have 3 other angle measures in your little baggie. Either one of them, it doesn't matter. Just pick one. Whichever one that you feel like it fits better and you can glue it down on. Now, I'm using Daniela's because she's not here, but make sure, and this angle right here did not come from Daniela's bag, but do you see how it's not actually cut along the angle? The whole point is that we actually get the real angle measure. So if that is what your angles look like, you need to trim that off a little bit so that it actually goes along with the angles. But the angles she cut out actually are right, and so we're good. Now, of these 3 angles, one of them actually works in this triangle too, but the other 2 do not. Which angle, before you even put them on here, do you know for sure cannot work? 80, because 80 plus 110 is 190. That's more than 180. 80 makes no sense. You can put 80 back in your bag. Then you've got 60 and 40 left. Okay, one of the two works in the triangle, the other one does not. So let's just think about this. Let's think about the 60. If one of the other angles is 60, then what would the third angle have to be? 10. Is that a possibility for a triangle? No, why not? Yeah, it's totally a possibility. You could have a 10-degree angle. So I could have 110, 60, and 10. Could totally have that. But what I know is, since I know my side lengths, I know that one of them is 6 and one of them is 5, right? Is that what we had? Okay. So 60 and 10 are a possibility. But I know that my side lengths are 6 and 5, right? So they're pretty close in measurement. And since they're pretty close in measurement, do you think the angles across from them would be that drastically different, like 60 and 10? Probably not. Okay, so instead of wasting my time trying the 60, even though we wasted time talking about it, we're going to take the 40 and see if it will fit in either one of the other angle slots. Because if one of them's 40, what would the other one have to be? 30. So does the 30 and 40 make a little bit more sense? Yes, because the side lengths are kind of close in measure, right? So when I put mine down, remember, yours could be flipped around different, so you can't just copy everything I do. I don't feel like my 40 really doesn't fit there. I wouldn't even say that's pretty darn close. But if I put it over here, I feel like that is a much better fit. Now, since I have the 40 and the 30, which with the other two angles, if one of them's 40, the other one has to be 30, my side lengths are 5 and 6. Would 40 be across from 5 or 6? 6, because 5 would have to be across from 30, right? And that's what's happening here. This is my 5 centimeter because I can see that it's shorter. We're not supposed to go by the way it looks, but we literally constructed this. I mean, we did it from straws, but we literally constructed it, so it should be pretty accurate. So 40 goes across from the 6, and that's where yours should fit, or at least be pretty darn close. Are we at least pretty darn close? Yes, awesome. Okay, so then go ahead and glue down a 40 on either triangle. You're actually going to, the 40 you have enough, we're going to do it on both triangles. We would have done the 110 on both of them, but if I'd given you two of them, but I didn't. So I'm going to glue the 40 down. And now, since that 40-degree angle is across from the side that has 2 marks on it, then if I take another 40-degree angle, it should fit in my other triangle that I didn't glue it down on. There too, and I can go ahead and glue that one down, since we have them. Yeah, glue a 40 on each. And we're just going to pretend like we glued a 110 on each. And then we don't have the 30s to glue down anyway, so we're just going to label them 30 and 30. Okay, so now, do you have enough to say that the two triangles are congruent? Yes, because we've just shown that all 3 sets of sides are congruent. We knew that to begin with. And we just figured out that all 3 sets of angles are congruent. And so, therefore, we know that the triangles are congruent, right? So let's answer some of these questions down here at the bottom. This says, what are the measures of the 3 angles in the first triangle? So that is 30 degrees, 40 degrees, 110 degrees. Right? And then the measures of the 3 angles in the second triangle, 30 degrees, 40 degrees, 110 degrees. So then, and think about this question carefully, what it's actually asking you. It says, what is the relationship between the angles of each triangle? What is the relationship between the angles of each triangle? Between the two. They're the same? All the angles are the same? They're all congruent? Roxanne, what you started to say what? Corresponding angles are what? Congruent. You have to be careful. When you say they're the same or all the angles are congruent or all the angles are the same, I know what you mean. But what you're saying is that they're all the same. Like they're all 60 or they're all 30. They're not all 30, right? So again, I know that's not what you mean, but that's what you're saying. And that's why we have to learn how to kind of, the first thing that pops in your head is probably they're congruent. That's great. That's right, sort of. Then we have to just be, we have to say it a little bit differently. And what it is that the corresponding angles are congruent, right? Corresponding angles are congruent. Not all the angles are congruent to each other. So then, are the triangles congruent? Yes. By the definition of congruent triangles, they definitely are. So can you take your straws that we translated to the pencil drawing on there, and arrange the 3 different colors in such a way that you get a triangle with different angle measures? No, because as soon as you put them together, I mean, it's the same thing every time, right? So the answer to this one then is no. So what we have come up with here is one of a few shortcuts we have to proving triangles congruent. Now, not everything we try is going to work, but this one works. And so since all we knew was that these 3 sides were congruent to these 3 corresponding sides, and that's enough to say the triangles are congruent, I don't have to know anything at all about the angles, then this is what is called the side, side, side. Now, if you can't write yours right there because of the way your triangle's spelled, that's fine. Just find a place to write it on the front. Side, 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 congruence postulate, or abbreviated as SSS congruence postulate, which says if 3 sides of one triangle are congruent to the corresponding 3 sides of another triangle, then the 2 triangles are congruent. And that's enough if we don't have to know anything about angles. Okay, we good with that so far? Any questions? All right. So then flip it over. All right, so set 2. Oh, where's my paper? Okay, hang on. I printed these out on white so that it would actually look decent under this document camera, and now I can't find the second page to the white. I guess I'm going to have to go gold, and that's not good, because then you're not going to be able to see it. What the heck happened to my paper? All right, I'm going to have to use the gold one. Story of my life. All right, let's just hope for the best. Well, that's better than it's been. Okay, so for set 2, here's what I need you to do. I need you to decide amongst yourselves at your table if you individually are going to use 60 or 40. I just don't want everybody at the table using the same angle. So you're either going to be a 60-degree angle or a 40-degree angle. And if there's 4 of you, then it's 2 and 2. If it's 3 of you, then y'all can fight it out, but I want it to be different. You're either choosing 40 or 60. I'm choosing 40 because it shows up on the paper better. Yeah, that's the only reason I'm choosing it. Okay, so either 40 or 60. Doesn't matter. And then I want you to take your 9-centimeter straw and your 5-centimeter straw. Your 9 and your 5, and either a 40 or 60-degree angle. And whatever, you're going to do this twice, so whatever angle you pick, you have to use it twice. You don't get to use one of each, right? And then you're going to line your straws up as sides of the angle like this, okay? And you want to do this, we're going to glue the angle down first, but if you glue when you glue the angle down, if you want to make sure your sides won't go off the paper, that's why you want to kind of line it up first so you know you don't put it too high. Once you know you could do that and the straw not go off the paper, then you can move the straws and glue your angle down right there. And then before the glue dries, you might want to double check that you actually hit the spot you meant to hit. Okay. Doesn't have to be exactly where mine is, just somewhere up there at the top. And then, yeah, then just make sure when you lay your straws back down that they're not going to go off the paper, because we're going to draw them here in just a second. Okay. Everybody with me? You understand what to do there? Okay, so at this time, instead of measuring with the straws, we kind of had to do that on the front just by the nature of that triangle. But here we're actually going to be able to use the ruler, so it won't be quite as complicated. But make sure it's glued down. Like, I can't move it, because if you're going to move it, then things are just going to mess up. Once you've got one of your angles glued down, then take your ruler, and you're going to make one of the sides of the angle 9 centimeters long, and the other side of the angle 5 centimeters long. Which we could have done the same thing with the straw. We just didn't want to make it too terribly complicated. Okay. And I'll tell you that you may run into, I'm not going to because I just started with a new piece of paper, but since you have something glued on the other side of yours, when you're trying to draw these straight line segments, you may have hit a bump in the road because you hit. That's okay. Just go with it. It's fine. And you're going to do this twice also. So then underneath this, And at any time, if your two triangles end up overlapping each other, it's not the end of the world. But if we can try to avoid it from the beginning, you would probably feel a little bit better about what was happening in the end. So I'm going to line it up again just to make sure that things may not overlap. And I think I'll glue my second one down right about there. Like so. So I've glued it down before I draw anything, otherwise I would never get it back in the same spot. And then once again, one side length is 9, and the other side length is 5. Or really, they could be anything as long as you're consistent between your two triangles. Everybody understand the instructions? I know you're not all to the point I am, but I just want to make sure we all know we're all at least getting there and not confused. And remember, don't obsess over it being perfect. You want to get it, I mean, you don't want it to be so sloppy it doesn't make any sense, but it's not a work of art. I'm not going to take it and hang it on the wall. I know, that disappoints you, doesn't it? Okay, so when we, on the front, we just had the 3 straws, so we just knew that all 3 sets of sides were congruent to begin with. This is what we're starting with, knowing about our triangle. We don't even have a triangle yet, and that's okay. But I know at this point that this line segment is congruent to this line segment, this line segment is congruent to this line segment, and these angles are congruent. You with me? So instead of having all 3 sets of sides, I have 2 sides in an angle. But which angle that is important. Okay, so I'm going to write that up here at the top. This is 2 sides and the included angle. Okay, that word included is important. Sorry, I know my hand's in the way when I use that. But 2 sides in the included angle. It is called the included angle because it is included in the 2 sides. Okay? Here's an example of a non-included angle. If I put this angle at 80 right here, and I ignored the 40, and I had these 2 sides in that angle, that is 2 sides in the non-included angle because the angle's not included in the 2 sides. You with me? Okay, so that word included is important because we're going to have included and not included with some of these, so I want to make sure you know what that means. I'm not actually using 80, I was just using that as an example. So is everybody at this point with me? So we are starting with, we know 2 sides in the included angle of one triangle are congruent to 2 sides in the included angle of another triangle. So then I want you to take your ruler, draw in the 3rd side of each triangle. Like so. Then once you get your 2 triangles drawn, yours may not look exactly like mine because remember we're not all even using the same angles, right? But when you look at your 2 triangles, do you feel like your 2 triangles are congruent to each other? Yeah, not even necessarily to your neighbor. Okay? What's wrong? Come on, draw on your side links, draw on your triangle, let's go. Okay. All right, so I would like to know if they actually, what the length of that 3rd side is. So with your ruler in centimeters, measure the length of the side and write it down on the side length, or on the side of it. I think this is the first time today that my 2 numbers were exactly the same. Woo. They're supposed to be the same, yes. But again, we're kind of aiming for pretty darn close. I think sometimes because when I'm drawing, I'm looking up at the screen, and sometimes I'm looking down at the stuff. I don't always hit everything where I'm supposed to. But if, for instance, I'd have got, like I got 6.2 and 6.2. If I'd have gotten 6.2 and 6.3, I would call that pretty darn close, right? It's all good. So do yours match each other, like your own, or at least get pretty darn close? Yes? Okay. If you used a 40-degree angle, were you close to about 6.2-ish? I mean, again, we may not have been the same, but it all has to do with exactly how it was. You might have been closer to 6. Some people got 6.5. If you had the 60-degree angle, what did y'all get? About 8, I think? 7.7, which is pretty close to 8, right? And but if you got 7.7 twice, that means whatever you did to make yours different than your neighbor's 8, you did the same both times, and then it's still congruent. It makes sense, okay? So we've got that those two sides should be pretty close in measure to each other. It's okay if you're a little bit different than your neighbor. So let's look down here at these questions. This says, what is the length of the third side? Okay, so you put your answer, whatever it is. Don't just copy mine because it may not make any sense to yours. Then it says, what are the measures of the remaining angles? Do we have the necessary tools to figure that out at this point? No, we do not. I'd have to put a protractor in your hand, and I can't handle that today, so that's not happening. It would take me an hour to make sure you knew how to use a protractor. So we're just going to put a little question mark. We don't really know. And maybe that's going to be a bad thing. We'll see. Then it says, are the two triangles congruent? Well, we know we have to do all three sets of sides and all three sets of angles to say the two triangles are congruent, and I just said, oh, we don't even know what the other angles are. But can I say that the two triangles are congruent? Yes, by what? SSS, right? I have, because we measured that third side, I know that all three sets of sides are congruent in both of them, and that actually is enough now. So yes, by the SSS congruence. Okay. Do what? Than me or than yourself? Like, how far off are you? I would remeasure, and just sometimes when you're off that much, like when you go back and really remeasure, see, I really feel like that's more like 6.4. And then on this one, I bet it's really probably a little bit more than 6. See, I would say that that's like 6.2. So then really it's 6.2 and 6.4, and you're not really off as much. Does that make sense to you? And it's just because it's not perfect and it's all good. It has to do with exactly how you cut that angle and exactly, well, here, I can tell you why. See how you didn't actually cut on the line of the angle? That's what's making the difference there. Does that make sense? You see the difference in his, how he like cut right on the line? That's what's making the difference in yours. Because this angle right here is actually a little bit bigger than that one. So you just adjust your numbers and pretend and it's fine. Okay? We're actually doing this with real measurements and stuff because I want you to see where it comes from and why, and not just me say, okay, make up these numbers and see this works, because then you wouldn't really see that it works. So close enough. But now we see why accuracy is important sometimes. All right. So will you always get the same result? What I really mean by that is if you have two sides in the included angle of two triangles that you know are congruent, do you think those triangles are going to be congruent every time? I mean, this is why we use different angles. Those of you that use 60, did you get two congruent triangles? Yes. And those of us that use 40, did we get two congruent triangles? Yes. Now that doesn't prove it forever and ever, amen. That proves it for those two angles. But if I used a 50 degree and a 70 degree, whatever, would the same thing keep happening? Yes, because you can only connect it so many ways. So the answer is yes. Which means this shortcut works too. And since this is two sides in the included angle, and again, I'm going to write mine right here because it fits. Yours may not, just depending on how you drew your triangle. Just put it on here somewhere. This is the side angle side congruence theory. Postulate. It's a postulate. But notice the order of the words. It matters because this is two sides in the included angle. The word angle is included in the two sides also. Okay, because we can rearrange these things and different things are going to happen. Yes, sir. Okay. Was that for congruence or similarity? Okay, so we're talking about congruence right now. We'll get to similarity right now in a little bit, but we're talking about congruence. So this is SAS congruence. Okay, SAS. Side angle side congruence. And you got to put the congruence after this because some of these work for similarity too, and that's probably where this might sound a little bit familiar too. I think you might have talked about these with similarity already, but okay, are we all good with this so far? All right, so the next one.